Start with complex numbers. First of all, we are going to see the representation of a complex number. Representation, how they are represented on a Cartesian coordinate system. It is denoted by Z, you can say anything. It has one real part and one imaginary part. This is called the real part, and this is the B is the imaginary. Well, IB is the imaginary part because you cannot calculate it. I is called iota. Its value is root of -1. Fine. So how it is? How can we plot it on the complex number? This complex number. Let's say this is C, which is equals to A plus IB. A is the real part, and this is the real axis. This is the imaginary axis. Just like we have coordinate system, this is positive real, positive imaginary, negative imaginary. So A plus IB, this implies this distance is A and this distance is B. So this is A plus IB, just like X comma Y. Fine. So this is the representation of a complex number. Now the conjugate of Z, which is a complex number. It is denoted by Z bar, and it changes the sign. It changes the sign of imaginary part. That is A minus IB. It does A minus IB. Where is A minus IB? It will be B distance from here and A this. That is A comma minus B. You can say it like this. But it is imaginary axis, so it represents A minus IB. So exactly this is a point on the complex number, complex coordinates. Fine. Now modulus of a complex number. The formula for modulus of a complex number Z is A plus IB. The modulus of Z is equals to root of the real part plus root of imaginary part. Okay, that will be B square. Fine. B square. So this is the modulus, or you can say the absolute value of Z. Absolute value of Z is equals to A plus IB. Now we are going to see the that if two complex numbers are equal, if Z1 is equals to Z2, then what conditions it must satisfy? First of all, real part of Z1 should be equals to real part of Z2, and imaginary part of Z1 should be equals to imaginary part of Z2. In that case, if you have X plus IY is equals to A plus IB, then X must be equal to A, real part is equals to real part, and Y must be equal to B, that is imaginary part is equals to imaginary part. So this is about the equality of two complex numbers. Now we will move on to the polar form of Z is equals to, let's say, X plus IY. Fine. So polar form of this is Z is equals to R cos theta plus I R sin theta. That means X is equals to R cos theta and Y is equals to R sin theta. And where R is equals to mod Z, that means R is equals to root of X square plus Y square, as we saw earlier. Or you can write R square is equals to X square plus Y square. Fine. Now if this is true, you can make a right angle triangle with this X, this Y, this, let's say theta, and this is R. Fine. Because X plus IY, this is X plus IY. Okay, this will be your X, this will be your Y, because R cos theta is X, so this will be X and this will be Y. Fine. Now it satisfies this equality. Fine. And this also satisfies this equality, these two equations. So this is the polar form. Now theta we calculate here. Theta, the argument, it is also called the argument. This is calculated in three ways. Tan inverse Y by X if X is greater than 0, pi plus tan inverse, it is plus not plus minus pi plus tan inverse y by x if x is less than 0 and y is greater than equal to 0, and if both are less than 0, what it will be? Minus pi plus tan inverse y by x. Okay, so this is how we calculate the theta, and hence we calculate this thing, r cos theta plus ir sin theta, that is the value of z is equals to x plus iy. Now we'll move on to formula, that is cos theta plus I sin theta. This is the polar form of a complex number to the power n. What is this? This is cos n theta plus I sin n theta, given that n belongs to r. Fine. So this is one of the most important equation of this complex number, related to complex number. Now we are going to see the addition and multiplication. A plus ib plus minus c plus id of two complex numbers. Addition and subtraction of two complex numbers. A plus ib plus c plus id will be a plus c plus I times b plus d, and a plus ib minus c plus id will be a minus c, fine, plus I b minus d. So this is the addition and subtraction. You add the real part to the real part, add the imaginary part to the imaginary part, subtract the real part from the real part and imaginary part from the imaginary part. No role of real with imaginary. Okay, so this is one of the formulas for addition and subtraction. For multiplication of two complex numbers, a plus ib into c plus id, this will be, first of all multiply these two, just like we have in real system, these two, then it will be I A D, then these two I B C, then these two I square B D. Now as we know, I is equals to root of minus 1, so I square will be minus 1, squaring both sides, so this is minus 1, so this can be written as AC minus BD, okay, these two terms, plus I times AD plus BC. So this is also a complex number. Fine. So addition, subtraction and multiplication of two complex numbers gives also a complex number. So now the division part. Division of two complex number, a plus ib divided by c plus id. This gives you AC plus BD divided by c square plus d square plus I times BC minus AD divided by again c square plus d square. How do we do this? We do it by rationalization. We multiply this thing with c minus id and divide with c minus id. Why? To make the base rationalized. C minus id. When you multiply these two, you will just have AC plus BD. Fine, because this is I square is minus 1 and IB into ID will be minus IBD, I square BD, I square is minus 1, so it will be plus BD, plus I, BC, minus AD, it's just like two complex numbers. Now for this, if you have A plus IB and into A minus IB, then it will be A square plus B square. Because this minus IB will be minus I square IB, minus I square B square, minus I square will be plus 1. So this will be plus B square. So that's why C square plus D square. And then you divide with each of them and you can see this. You separate out the formula. So this was about the division of two complex numbers. Now we'll move on with the argument. The argument of Z is represented by ARG Z. This is tan inverse imaginary part of Z upon real part of Z. Fine, this is imaginary part of Z upon real part of Z. Or you can say theta, which we calculated earlier. Now if theta belongs to minus pi to pi, this implies theta is the principal argument. Fine. This is the range for theta being a principal argument. Now let's say we have alpha is equals to tan inverse y by x. Fine. Now then theta will be alpha pi minus alpha minus pi plus alpha, just like the earlier case, and minus alpha. Alpha if it is in first quadrant. Fine. If alpha's value lies between 0 to pi by 2, then this will be the theta. If alpha is between 0 pi by 2 to pi by 2 to pi, then we will subtract alpha from pi. So this is for second quadrant, this is for third quadrant, and this is for fourth quadrant. This is in this alpha belongs to 3 pi by 2 to 2 pi. Fine. So this is the case. So you got to remember these, because this has been many times asked in JEE exams, and it is their favorite topic. So a complex number. So you got to prepare it. Now the Euler's form. Z is equals to R cos theta plus I R sin theta is equals to R e to the power I theta. Euler defined this cos theta. He took out the R common, then cos theta plus I sin theta. He defined this quantity as e to the power I theta. Okay, this quantity as e to the power I theta. So this was the work of Euler. And for him, the Z bar will be e to the power minus I theta, because e to the power minus I theta will be what? R cos of minus theta plus I sin of minus theta. That will be what? R cos of minus theta is again cos theta minus R I sin theta. Sin of minus theta is minus sin theta, so minus taken common out. Fine. So this is your R cos theta minus R sin theta, which will be Z bar, because in bar we do the negative of the imaginary part. Okay. Now we are going to see some properties related to two complex numbers. So first one is mod of Z, which is equals to root of, let's say, x square plus y square. For the case Z is equals to x plus iy. Fine. So mod Z is this, then mod Z bar will be also this. Mod Z bar is also this, mod of minus Z is also this, and mod of minus Z bar is also this. Because this is the root of real part plus imaginary part. So square root of real part square plus imaginary part square. Imaginary part is y. If it is negative, then negative y whole square. So that will be also y square. Capital will be positive y square. Then the second, which is the most important of all properties, and it is always used in JEE exams, so remember this. Z dot Z bar, okay, is equals to mod Z square. In case you find any question with not specifying Z, what is Z, x plus iy, and not specifying this x and y, not giving you any numbers 2 and 3, then you have to play with Z only, and in that case this will be too much helpful. So Z dot Z bar will be mod Z square. This is simple to prove, so I'm not going to do this, because you have to just multiply to complex number and see that this is coming out this. So this is important property you got to remember. Then you have Z1 plus Z2 whole mod square will be equals to mod Z1 square plus mod Z2 square plus 2 times real part of Z1 Z2 bar. Fine. This is also important. Then you have Z1 plus minus Z2 is less than. Now these are three properties which are very important. Let me write it on another page with another pen. Okay, first property is mod of Z1 plus minus Z2 is less than equals to mod of Z1 plus mod of Z2. Okay, this is also called the triangular property. Then you have mod of Z1 plus minus Z2 is greater than equal to mod of Z1 minus mod of Z2 mod. Okay, the sum of two complex number, the mod of them is always less than equals to individual mod, and is always greater than equals to the subtraction of, when we subtract two complex numbers Z1 and Z2 and take the mod of that. So this is the minimum value, this is the maximum value. Fine. Now we have Z1. Well, this is not important, so I'm not going to that much important. You can just prove it. So mod of Z1 Z2 is equals to mod Z1 mod Z2. Fine. You separate the mod out. Then you have mod Z square is equals to mod Z square. Again, a simple property, can be easily proved. Then we have Z1 plus minus Z2 bar will be equals to Z1 bar plus minus Z2 bar. This is also easy to prove. You have to just add the two complex numbers. Then you have Z1 Z2 bar is equals to Z1 bar dot Z2 bar. Fine. You separate the bar out. Then if you have division Z1 by Z2 bar, you can also separate out here Z1 bar by Z2 bar. Then if you have mod of Z1 by Z2, this is also important. It can be written as mod of Z1 by mod of Z2. Fine. So these were the properties related to the complex number. And now we will see some properties related to argument of a complex number. First property, argument, which was theta, which I explained earlier. Argument of Z1 Z2 is equals to argument of Z1 plus argument of Z2. This is important. This has also been asked in many times in JEE. Okay, then we have argument of Z1 by Z2 is equals to argument of Z1 minus argument of Z2. Fine. Now let's say we have an Argand plane. This is Z1. Okay. Here is Z2. Then you have Z3 and Z4. Fine. Now these will be also connected. Okay. So the thing is, the argument of Z1 minus Z2 upon Z3 minus Z4. How to calculate this? So first of all, what we will do? We will do this part, Z1 minus Z2. We will be given complex numbers, so Z1 minus Z2 divided by this to prove this inequality, to prove this equation. So Z3 minus Z4, we will do this, Z3 minus Z4, Z1 minus Z2. Okay, so you will get something like this angle and this angle. Fine. So when you will subtract them, then you will get the subtraction part, which will be some angle in between. Okay, so that will give you the insight that argument of Z1 by Z2 will be equals to argument of Z1 minus Z2. Fine. You can take 6 complex numbers defined on the hexagonal plane. Then you can have 8. Okay, you can extend it to any number. So this is the thing. Now the next property is argument of Z. Argument of Z does not exist or is not defined if Z is equals to 0. That is, imaginary part and real part both are 0. Then 0 by 0 is not defined. It will be equal to pi by 2 if x is 0 and y is greater than 0, and it will be equal to 3 pi by 2. These are things to remember because this can be easily used in JEE exams. They are directly related to the question. X is 0 and y is less than 0. They'll just give you that this is the thing, this is the condition. In each question there is almost 3 to 4 conditions. So according to the conditions you will derive the formulas. Now the most important theorem related to complex number called de Moivre's theorem. De Moivre's theorem says that we have two cases. First case, case 1 suggests us that if n is equals to integer, then cos theta plus I sin theta to the power plus minus n. It can be anything, minus 2 plus minus, okay, minus 3 plus 4. Then this will be just cos n theta plus minus I sin n theta. Fine, this is the case. But now this is the thing to remember. I also did this mistake in JEE, so I am telling you. Sin theta plus I cos theta to the power plus minus n is never equal to sin n theta plus minus I cos n theta. This is never done. Okay, this n. So you have to remember that this is cos theta always and this is sin theta always. You cannot exchange them, you cannot interchange them, you cannot put tan theta, cot theta, anything in there. This is defined by Euler and he did for this case only, not for any case. So cos theta plus I sin theta. R cos theta is x, y is R sin theta. So this was the first case. Then we have case 2. Case 2 suggests that if p comma q are integers and q is not equals to 0, okay, then cos theta plus I sin theta to the power p by q, this will be equals to cos of 2k pi plus p theta by q plus I sin 2k pi plus p theta 2k pi plus p theta by q. These angles are same, okay, 2k pi plus p theta by q. So this is the generalized case for if you have a fraction in the power, okay. So